Hi, Mrs. Spohn here, and I'm bringing you another screencast. This one's on ionic compounds, and we're going to talk about naming ions, naming ionic compounds, and writing ionic formulas from the names of ionic compounds. And we'll take a look at the transition metals as well and see how to write formulas for them. So the first thing we want to do is identify some anions and cations. Recall that metals, everything on the left on the periodic table, the left of the stair-step line, they form cations. They lose electrons and they have a positive charge. Nonmetals are going to gain electrons, and we call those anions, and they're going to have a negative charge. And this is a very nice graphic of that, and it kind of breaks the periodic table down. You can tell that it's broken down by columns. All these elements in here want to lose one valence electron, and they'll have a +1 charge. The elements in column 2A are going to lose 2 electrons, have a +2 charge. And when we jump over to the right side, elements in column 7A, the nonmetals are going to want to gain 1 electron. These are going to want to gain 2, gain 3. So these are the respective charges of our ions, and we covered this already. Notice these elements in the middle, these transition metals. We didn't cover these yet, but these have something called the variable oxidation state, and they're going to behave differently than our standard dot structures, or they're going to behave a lot differently than representative elements. And each one of these can have different states. Iron can lose 2 electrons, or it can lose 3 electrons and be stable. And you'll never ever have to memorize these, but you're going to have to know how to use them and write chemical formulas with them. And we're going to do that in this video. So simply, what is the charge of a calcium ion? So if a calcium atom loses electrons and it becomes an ion, what is its charge? And simple question, calcium will form a +2 charge. It's in column 2A. It loses 2 electrons. And how do we name ions now? Well, simple rule. Cations, all the metals that lose electrons and become positive, they keep their name. Lithium, it's called a lithium ion. Sodium, +1 means it lost an electron. It's called a sodium ion. We don't name it anything special. Potassium, rubidium, and so on. Oh, what I want you to do as an assignment is I want you to name the rest of these. And yes, this is that easy. These keep their name. Anions, it's a little bit different. When you have an anion, when you have a nonmetal gaining an electron, we take the end of the name and we swap it out with IDE. So fluorine becomes fluoride. Chlorine becomes chloride. Selenium becomes selenide. So I want you to basically fill in the rest of these in your notebook and just name them. See what you can come up with. Bromine's going to become. Nitrogen's going to become. And that one might be a little more tricky because there's 3 syllables in that word, but I think you can figure it out. So name the rest of these elements. And the rule again is that anions, we change the N to IDE. And now how do we name ionic compounds? And recall that the name for table salt, which is a combination of sodium and chlorine, is sodium chloride because we have a sodium ion combining with the chlorine ion. And whenever you have an anion, an atom that gained an electron, we have to change the name to IDE. That's why Mr. Zapone always calls table salt sodium chloride and not sodium chlorine. Same thing with, these are all going to be ionic compounds, and we have barium and chlorine here, and when they're in an ionic compound, it's barium and chloride. So we call it barium chloride because this is an anion, that's a cation. So I want you to go through and also name the rest of these using the same principle here. The name of the cation followed by the name of the anion. Relatively straightforward. Do that in your notebook as well. And now we're going to look at writing ionic formulas, and this is not too bad. Just realize that there is one simple rule here. The net charge of an ionic compound must always be 0. So when we have sodium chloride or table salt, the charge on a sodium ion is +1. The charge on a chlorine or chloride ion is -1. Together that adds up to a total charge of 0. This whole combination, if you were to put a circle around this, all of these atoms, the total charge inside must equal 0. And that's the rule of thumb for ionic compounds. And we're going to look at the rest of these. And while you're doing this, you're either going to want to have a periodic table so you can figure these out, or basically maybe when you're done watching the video, you can look at the PowerPoint I put online and you can go through that. But you're going to need to know the charge of each one of these ions to do this. So we have barium and chloride, or the chlorine ion. So barium has a +2 charge, chlorine has a -1 charge. if I put a circle around this, all the charge inside is going to add up to a +1. Because chlorine's a -1, barium's a +2. So that doesn't work. So what's going to happen is I'm going to need another chlorine atom here to balance this out. And now we have barium with a +2 charge and 2 chlorines with both -1 charges. And that's going to equal a total net charge of 0. That's why barium chloride is always a combination of 1 barium atom, or 1 barium ion, and 2 chloride ions, BaCl2. Same thing's going to happen with lithium and oxygen, except for lithium has a +1 charge, oxygen has a -2. You need this whole charge to equal 0. So we're going to have to add another lithium atom to the mix. Now we have +1, which is a +2, and that cancels out with this -2. So whenever lithium and oxygen come together to form an ionic bond, it's going to be lithium 2 oxygen, or Li2O, lithium oxide. And then if we had magnesium and oxygen, magnesium is going to have a +2 charge, oxygen is going to have a -2 charge. So they're going to bond in a 1-to-1 ratio, MgO. And here we have calcium phosphide, Ca3P2. Ca has +2, P has a -3. So let's add a calcium ion here. Well, still doesn't add up to 0. We have +2, which is a +4. And that's a -3. That doesn't add up to 0. Now we have too much charge here, so let's add another atom to the other side, another ion. Well, I think I skipped a step here, but this is where we have to end up. We have to have Ca3, +2, +2, +2, and it has to balance with 2 -3s. And the point of this is, if you ever told a chemist, or if you're reading something and you've seen the words calcium phosphide, well, you should know that that's going to be 3 calcium ions and 2 phosphide ions together, because calcium and phosphide can only combine in that ratio, so that the total net charge inside equals 0. So generally, when you're reading something like this, you should be able to determine the charge just by reading these words, the formula. So what I want you to do now is go through on these combinations. So we have combinations, say strontium and chlorine. If those two atoms, if they basically formed ions, what would you name them if they combine together? And write their chemical formula, and what ratio would these atoms exist with one another? And what ratio would calcium and oxygen combine? So name these formulas and write their ratios. And now we're going to look at the transition metals. And notice we said earlier that these can vary. Iron could have a +2 charge or a +3 charge. So iron can lose 2 electrons, or it can lose 3 and be stable. Copper can lose 1, or it can lose 2. Gold can lose 1, or it can lose 3. So these can differ. And again, you'll never have to memorize these ones. These ones you should generally know because of column numbers and dot structures and kind of what's going on there. But the transition metals, no, we don't have to memorize those. But we do have to use them. And since iron can have 2 states where it's stable, or 2 ionic states, chemists have to have a way of distinguishing between iron 2+ and iron 3+. So we do that with Roman numerals. Iron 2 chloride, that's going to be Fe2+. Iron 3 chloride is going to be Fe3+. And again, if you wanted to write, I don't know, copper 2+, it would be copper 2. And if it was combined with something else, copper 2 chloride or something of that nature. So that's how we do that. We use Roman numerals to distinguish between the type for transition metals. And we have to do that only for transition metals, but it has to be done. So how would we write the chemical formula for iron chloride? If I asked you on a test, what is the chemical formula for iron chloride? Well, I'm being a little bit vague, and I'm expecting you to know by looking at a chart that iron is going to have 2 very common ionic states, +2 and +3. So you'd actually have to do both cases. Iron 2 chloride, we have iron with a +2 charge, chlorine with a -1. And the game principle applies. These charges must add up to 0. They do not. As you might expect, we're going to have to add another chlorine atom here. And then it will add up to 0, the total charge. And that's exactly what happens. And if we look at iron 3 chloride, iron has a +3 charge. Chlorine has a -1. What are we going to have to do? Well, we're going to need 3 chloride ions. We're going to need 3 chloride ions, -1, -1, -1. And that'll balance with the +3. And of course, how would we write the chemical formulas for these? Well, over here we have 1 iron ion, 2 chloride ions, so FeCl2. Over here, 1 iron ion, and we have 3 chloride ions. So this is iron 3 chloride. This is how you would write it. Roman numeral way and regular formula way. So now you have an assignment here. Vanadium oxide, 2 oxide. Vanadium 3 oxide. Write the chemical formula for it. Iron 2 oxide, iron 3 oxide. Manganese 7 oxide. Well, that's a little bit of a weird one. But that is your assignment. Just complete these formulas for the transition metals. Use the chart that's in the PowerPoint to help you. And hopefully you have a good understanding or a better understanding of how to name ions and write ionic formulas and figure out in what ratio ions will combine in. Mr. Zapone, I'm out.